Welcome to the API Hour, or as we like to call it, Appy Hour, the podcast where APIs meet InfoSec and vulnerabilities don't stand a chance. I'm your host, Dan Barahona, and each week we dive into the world of API security, from real-life breaches and testing tactics to the people, tools, and trends shaping the future of AppSec. So whether you're a builder, a breaker, or somewhere in between, this is your front row seat to the conversations that matter. So grab your headphones, it's time to plug in, lock down, and decode what's really going on with APIs. This is the API Hour. Super psyched to have Scott Bly with me today. He's caffeinating up. Are you ready to rock?
Getting it done, man. I'll continue to caffeinate up, so be forewarned. The caffeination level will increase as the talk goes on.
All right, let's open up the chat here. Hey, everybody. And we always love to know where you're joining us from. So today's topic is one that I actually am super interested in because I never really thought I fully understood what DevSecOps is. Is it a concept? Is it a process? Is it technology? And we were fortunate enough to grab Scott Bly, who knows this stuff in spades, and he actually created a whole course for us on introducing API security and DevSecOps into your organization. If you haven't checked it out, please come to AppSec University and check out his brand new course. We actually have just crossed 1,000 students in the course, so it's been super popular. And Scott, thank you so much for being here. Thanks for being one of our instructors.
My pleasure. Thanks for having me. I really appreciate it. It's a lot of fun to put that together. Yeah.
I want to introduce Scott. Is a guy I've gotten to know over the last year. Absolutely outstanding individual. Someone you definitely want to follow and get to know. Scott, give us a little bit of your background, because man, when I edited your course, I was just like, holy crap, this dude knows this stuff so incredibly well. Like, how did you get here?
Well, I appreciate the kind words. I've been doing IT for a long time. My degree in theater and film didn't exactly prepare me for a career in cybersecurity. I kind of jumped in feet first. I always had my nerd creds were always deeply rooted. You can take the boy out of the nerd, but not the nerd out of the boy. I'm not sure what the appropriate phrase is there, but I had always been kind of a tech guy, right? And so when I pivoted away from the creative part of the film business pretty early on, I ended up working in databases and whatnot and ran a consulting business for about 15 years, Microsoft Consulting, Mac, small, medium-sized business networking, et cetera, and just really continued doing a lot of that work for a long time. And then I became an IT director, sold that business, and then eventually landed at AWS and then later on at No Name Security. So kind of going deeper and deeper into the cybersecurity side of things, ended up getting a lot of certifications through the process. So kind of bolstering that real world experience of how do you secure environments? How do you look at a customer's environment, somebody else's responsibility where they have to secure their workload, and help them understand where their gaps are, right? That's a lot of the work that I did at AWS and as a consultant as well. And so having that certification knowledge as well is also helpful, because then in my view, what that really does is helps you bolster your own knowledge base to make sure that you don't have any gaps, or that in my case, I don't have any gaps in my knowledge. And I still do. There's tons. I don't know everything by any stretch of the imagination. But when you go get your CISSP or your CSSLP from ISC2, that's a body of knowledge that when you go and take the test, you can be reasonably assured that you know the stuff well enough to be able to converse about it fluently. And so I feel like I'm pretty good at the conversing part, but we always make sure that we have really amazing engineers on our consulting team to go do the actual work.
The theater background definitely comes through, and I know you're based in LA, so maybe this course is going to get you discovered, and we can all say we knew Scott when.
Yeah, I'll be guest starring on Rick and Morty or something soon.
Certainly got the voice for it. You can't talk about DevSecOps without some sort of like infinity diagram, right? Like, There we go. This says DevOps lifecycle. So are we going to see a DevSecOps infinity diagram at some point?
We'll get there. Absolutely, Dan. Thanks for setting it up. But I always like to look at DevSecOps with the background of DevOps, right? DevOps is now a very, very well-established practice, right? It's not just one thing that I do see a lot of organizations do is they say, oh, we have this thing that needs to get out. We'll throw it over to DevOps, right? What they mean is the person who has admin credentials to AWS or to their GCP environment. That's not DevOps. That person is not DevOps. That's just a job title, right? They're kind of missing the point. DevOps is this continuous life cycle that we hear on. It's both the development side and the operations side. And it's intended to enable you to get code to market faster, right? The devs are there to make sure that they're getting whatever the marketing team needs for product to be able to get to market so you can meet your revenue obligations or whatever. The operations team is there to make sure that it's running and that it can happen reliably. And DevOps has kind of brought this way of functioning together so that you have a repeatable, predictable way of making that happen in an increasingly rapid and reliable way.
So you got to dumb it down for me a little bit, right? So DevOps came first, DevSecOps came later. Like
Yeah.
pre-DevOps was Dev and Ops really like two distinct things? And this was like a revolution in actually saying, wait, Dev and Ops really need to be intertwined?
Yeah. Before you had DevOps and kind of agile methodologies, you had waterfall. In the course, we go over this quite a bit. But once upon a time, people would say, think back to the old school Microsoft days where you'd go buy Windows 98 and you would get an updated version of Windows that gets released every few years because it takes that long to be able to have a project go from here's what we envision, and you march your way through all of the steps that are necessary to get to that finished product, and it comes out. It's kind of like the way that rockets, I know they're still developed this way, but SpaceX has taken that model and turned it on its head. Rockets used to be, we're going to go to the moon. To get there, we need to do all of these things. And therefore, you have all of the pieces that are built and they're tested extensively until finally they're like, okay, we have it. And it launches and it does go to the moon. But it took a long time. It's wildly expensive to get there. Cost overruns in space development are like very well understood. There's the cost plus model, which is perhaps a poor incentivization strategy for that. But SpaceX comes along and says, we're going to do it different. We're going to build a rocket with our best ideas and launch it and see what happens when it blows up. And then eventually they stop blowing up, and they've learned from every one of those iterations. And that's the development lifecycle: develop, test, build, develop, test, right? They're going, we think we have this idea of what we want to do. We're going to try it out. Did it work? No. What do we need to change? Now we're going to make an adjustment. And you have the same thing happening in software. And for a long time, we'll get to this in just a minute as well. The idea was that this actually all comes from lean manufacturing, which Toyota kind of developed in the 70s. They were just beating up all of the US car manufacturers.
That kind of thing.
And so what Toyota would do is if there was any defect at all in their production line, and this is where you get over here to the operation cycle. But what Toyota did is they established this way where if there was any defect that occurred at all in the production line as a car is going down the road, somebody could reach up and pull the and-on cord, and that would stop the entire production line. That would signal everyone that was an expert in their field to descend upon the problem, solve the problem for good, get the production line moving again. Well, the Americans all thought that was crazy. If you got a problem with a seat, why would you shut down the entire production line? It's too expensive. But what that did is it made sure that every single error that can be caught is caught, and you end up with an incredibly reliable vehicle. And over time, what that ended up doing is creating cars that were super, super reliable. And that's how Toyota ended up being able to do that and also bring their costs down. Because if you don't have any errors, you don't have any cars coming back, that's better for your bottom line. But Toyota releases this, but everyone was saying, how can we do this in software? That doesn't seem like that works. But then you have, and this is what's talked about in books by Gene Kim, the Phoenix Project. Everyone on this call, the Phoenix Project should be required reading. I'm not joking. Get it. It's fantastic. The Phoenix Project is great because it takes the whole concept of Toyota lean manufacturing, which was popularized in the United States with a book called The Goal by Eliyahu Goldratt, I believe is his name. He made a novel about Toyota's lean manufacturing technique, and Gene Kim and his associates did the same thing with the Phoenix Project. They wrote a novel about DevOps because there were all these companies that were doing it. Google, Pinterest, I think Yahoo, eBay. These were all companies that were like figuring out how do we get code to market faster, more reliably, in a way that resembles Toyota's lean manufacturing process. And they were successful, but people couldn't quite wrap their heads around how to do it. And so the Phoenix Project is a novel that explains those concepts. And most importantly, it gives everyone who reads it a shared language. When we're talking about DevOps, what do we mean? What are we really talking about, right? So the Phoenix Project does that, primarily focusing on the operations side, right? The Unicorn Project came out later and is the same story, and is from the developer's perspective, right? And so it's kind of like I believe it was Rashomon, the old Akira Kurosawa film. Was it Kurosawa? I'm pretty sure it's Kurosawa. And they tell the same story multiple times from different perspectives. Gene Kim has kind of done that with the Phoenix Project and the Unicorn Project, but it's focused on the dev and the ops side in those two different stories. So really, really good if you're looking at how to deploy DevOps or improve your code lifecycle overall. These should really be required reading. And then the DevOps handbook is more case studies from the real world. How did Pinterest do these things? How did these different companies accomplish DevOps in their environments? Happy to support.
Let me bring some comments in here. And
Cool.
there's one from Thomas. The analogy I use to explain DevOps is military special forces. Each member is highly trained and motivated. Each member specializes in specific fields, developer, QA, infrastructure, but each member can take over each other role if needed. The DevOps member knows a bit of everything. In the end, the actual industry implementation of DevOps is kind of meh, besides some examples from Netflix. Thoughts on Thomas's comments? It's actually a really interesting way to put it.
It is. However, I would argue that that's not actually a DevOps concept. I would argue that that's a really effective cross-team, cross-functional training exercise that enables high availability within your teams. DevOps, if we go back a link here, is really about making sure that you can accomplish these cycles, right? But if your teams are cross trained so that your different folks have the ability to cover for each other, that enables high availability within your dev or your ops cycles, right? The DevOps is really about making sure that you're not skipping any of these stages, right? How often have you had folks go, hey, I'm going to go do this thing, and they skip the planning stage and they're just already writing code? It's much more expensive to do that. If you figure everything out ahead of time, right, you're much less likely to make the mistakes that are harder to fix once you've got it in build and test and release and all this. Or how many times has the testing been shortcutted? You don't really know if it's going to work, but it's out there and you're operating it, trying to monitor it and run it in prod, right? So that's kind of that's how I look at DevOps. But you raise a really great point, Thomas, that there are lots of ways to do DevOps. Some folks just say, throw it over the wall to DevOps. And other teams say, no, we've got a real process around this. So I think what you're describing is an excellent way to implement DevOps.
Yeah, no, by all means. And so we've talked about DevOps, right? And the purpose of today's call is DevSecOps.
Right.
The first thing that comes to mind is, did DevOps just not give a crap about Sec all these years? And that's like, yeah, that's that other team's problem. Like, and the big like revolution here is that actually Sec is relevant here. We ought to like weave it into this infinity loop here.
Issue, DevOps has been wildly successful, right? So now you have thousands and thousands of developers. The ratio is about 1,200 developers to one AppSec engineer. You have thousands of developers that are able to get code to market really fast. DevOps has enabled that code to get out and for it to run successfully. If we just look at the inside part, you've got developers able to get stuff out fast, and then it's operating and working really, really well. The problem is that exceeds the ability and speed of the security folks to be able to make sure that those workloads are secure. So you see this increase in breaches and hacks and all this other stuff. There are other extenuating reasons for that, like the NSA accidentally letting their top secret weapons out into the wild when they themselves got hacked. But that was 10 years ago, right? So there are reasons why we've seen an increase in hacks, but a lot of it's also, there are more vulnerabilities that are out there that can be exploited. So the way to improve upon your organization's ability to deliver code securely is to use DevSecOps, which is adding security into the entire DevOps lifecycle. Now, many organizations start that process, and this is kind of the name of our session today, which is breaking the build before hackers do. And I'll explain what that means. And thanks for the excellent title. Where many organizations start is here at the testing phase. They go, oh, we're going to do DevSecOps. Now what we're going to do is we're just going to add security testing to the test phase of our DevOps lifecycle that's pretty mature already. And we have DevSecOps. Well, that's sort of true, right? It is a step in the right direction, and it's an important piece of the puzzle. But what it doesn't do is address the entire rest of the life cycle. Your organization should at least be aware of each of these 14 steps around the security life cycle. And so what you need to do then is identify what makes sense for your organization. And in many cases, starting with testing is great, right? It's definitely better than not having security testing in your CI/CD pipeline, et cetera. But there's more to it than that. So you have this continual life cycle with all the little shield marks that are around the outside edge there.
One thing that stands out here is, right, so we added Sec into this DevOps loop, but it's right dead center in the intersection. What is there some significance to that? Like, are they saying it's like it's just part of the entire loop here?
Yeah, I think that's a really nice because you've got dev and you've got ops, right? DevOps on each side, and when you add security as an inherent part of everything you're doing, it puts security right in the center. So that's really just an illustration. But the implementation of DevSecOps really happens at each stage, right? So you've got threat modeling at the planning stage, right? If you're reviewing an architecture before you've written any code to determine where your trust boundaries are, what are the different threat actors, what are their motivations, how are they going to try and get in? Have you used encryption as the simple example? And if you're doing that at the napkin stage, then you're doing a threat model. If you're doing it once you've already got stuff out in the field, then what you're doing is really a security review, like a security analysis. So in the bottom right, you have security analysis. That's really looking at a deployed architecture that's really running. That's no longer a threat model. That's something that's a little bit different, right? But if you're planning and doing some analysis of what could go wrong ahead of time, then you're really doing threat modeling. I think Eric asked a question. What are your thoughts about folks who say security is really quality testing? I actually agree. When you're talking about it in the testing stage, right? That's really what it is. You're making sure that your environment is secure from unintentional denial of service or whatever. Because remember, security really boils down to the CIA triad. Confidentiality, is your stuff secret? Integrity, has it been manipulated, or is it maintained the way that you think it's supposed to be? Is a one still a one, or is a zero still a zero? And then availability, is the workload available to the right people at the right time? That's what everything in security is about. And quality testing is making sure that if you type in the wrong thing, or if you have a type form that gets overloaded, is it going to time out, right? Is it going to be rate limited or reach its limit? So I agree. I think that's exactly what it is. But it's a very specific kind of quality testing that looks at, SQL injection available and other sorts of things.
So let me maybe bring this to like APIs and applications and all
Sure.
that kind of thing, right? So I think maybe the old model was you developed, right? Did your test, whatever. It went into ops, right? So you pushed it live into production. And security was its own totally other group,
Yep.
right? That was like, all right, make sure this stuff is secure. And security tended to be like stop brute force attacks or, things that have like sort of some sort of detectable signature to it, right? Unusual traffic, spikes in traffic, malicious payload, stuff like that, right? And that's where like we saw the firewall morph into the web app firewall and all these kind of things, right? What we talk a lot about is like with applications, right? And
Mhm.
in our workshops that we do a lot, right? We're like, look, here's what happened to Peloton, here's what happened to Venmo, here's what happened to Coinbase, right?
Yep.
And those attacks made it through those defenses, those detections, right?
Yep.
And we make this point about like the reason why is they don't look like attacks, right? They look like normal traffic. So, you can't bolt on security to after the fact or in runtime. You should do the things that you can do in runtime. You should do bot detection and brute force, all that. But the really like sophisticated stuff gets on through.
Yep.
So A, do you agree with that? And B, does that reinforce why security has to be woven into this DevOps lifecycle?
Yeah. The whole idea, when you talk about DevSecOps, I said it's not just about testing, it's the whole life cycle, right? So that's DevSecOps. The other term that you hear thrown around a lot that's sometimes used interchangeably is ship left, right? So if you think about a timeline of code gets written, and so for me, this is left to right. I'm not sure if it's left to right or right to left for people on screen, but this is my left hand, so it's from left to right. You write your code, you deploy your code, and then it's running in production. Bad guy does a bad thing to something in production. That's on the right hand side of your timeline. So that's kind of a shift right mentality. Everything right of boom is incident response, right? And that's what you're describing with the bolt-on security. Like that tends to look at stuff that's running in production. You've got web app firewalls that are watching for bad guys doing a bad thing at a particular time. That's important, especially for monitoring, which you see here on the right-hand side at the bottom in your operation cycle. That's an important part of DevSecOps. You need to monitor your production workloads. What you're describing, Dan, is the shift left process where you start to fix your security vulnerabilities earlier in time, preferably at the testing stage or at the build stage or at the develop or even at the planning stage. The earlier you get to it, the more effective the fix is and the cheaper it is and the faster it is. So it's a much more effective way to get there. but it's a process to keep moving things left. I saw somebody ask how many claim they run DevOps, but in reality, they just do some automatic build stages combined with a lot of manual steps and still have a big gap between development and operations. And that's accurate as well. But that has to do with how mature is your DevOps organization and how mature is your DevSecOps organization in terms of how you're utilizing these automated testing procedures. And what is your feedback cycle? Because notice that this infinity symbol it's twisted for a reason, right? The development cycle continues on its own until it's got something ready to kick out over to the operations cycle.
Oh,
And the operations cycle runs for a while until it's ready to kick back information that we've learned from our running workload back into your planning stage. That feedback loop is incredibly important. And it's talked about in the Phoenix Project, in the DevOps handbook, et cetera. But these feedback cycles are intentionally informing each other. And part of DevSecOps is making sure that your development security findings are fed into your security operations center, your SOC team, and your SIM tooling, so that the security team is aware of what's happening on the dev side. So they can see, hey, we have teams that are pretty consistently having security issues of this kind come up in their development and their testing. The way you do one thing is the way you do everything. Therefore, that means that probably we got a lot of production workloads that have those same vulnerabilities that we don't know about. And so they can develop hypotheses and go do threat hunting exercises to find out whether or not those hypotheses are true. Do they really have those vulnerabilities in production that they're not aware of, that are being exploited in the wild, that haven't been detected? And then you can write detection rules on the right.
so I've always wondered why this is an infinity instead of just a big like oval loop, and you've answered the question. So these are two different cycles that then
Yeah.
intersect at some point here, and I guess to turn DevOps into DevSecOps, security is now sort of like woven throughout the thing. I remember in your course, you're like, security isn't one point in time. It's like every single one of these elements involves security. And I want to dig deeper into that, but I want to bring up Eric's comment. You briefly mentioned threat modeling, something close to my heart, having trained under Adam Shostak. What are your thoughts about getting executive buy-in to do threat modeling earlier in the cycle?
Yeah, that's a great question, Eric. Excuse me. Ask them if they would rather identify a threat actor before or after the code is running and has access to production customer data. I think that's a pretty straightforward question. And what does it cost, right? There are applications that can scan like a Windows machine and say, hey, you have all this PII on your Windows machine. According to the insurance industry, that means you have this exposure and cost that you've created just by having this data exposed on the Windows machine, even in just a non-encrypted state. You have the same kind of exposure happening when you've got running workloads in production. If PII data gets out, you have a requirement to disclose. It impacts your ability to win customer trust. You could lose business. You have fines, regulatory compliance, all that. All that stops if you do the threat model and don't have the vulnerability in the first place. It's thousands of times less expensive to do the threat model upfront. So just put it in dollars and cents.
We actually cover this in a little bit in the API security fundamentals course, right? And it's like, APIs have been this elephant in the room. It's bizarre. Even today, right? Like we
Yeah.
scan our front ends, we do this, we do code scanning, we do all these things, right? But, organizations still largely, hopefully it's improving, don't have that same level of depth on their APIs.
That's true.
And if your APIs are connecting to backend systems, they're talking to the database, they have access to, features and functions, all that. Why are you not doing that? So threat modeling critical. I got to address Andrew Goslin. What AI platform would be best for BOLA testing with Postman? I got to make a little plug here.
Yeah, I was going to say that sounds like our beneficiary, our sponsors here.
Yeah, exactly. Here, set up free AppySec account. Andrew, BOLA is the number one hardest thing to find, as far as I can tell, in APIs. And BOLA, broken object level authorization, can user A access user B's data. In fact, we'll do a workshop in a couple of weeks. But just 2 weeks ago, there was an outstanding piece of work done by Ian Harrison and Sam Curry. They actually spent some time on McDonald's job application site, mchire.com, and they played around with it. They have a chat bot that helps you apply for jobs at, your local McDonald's and all this stuff. And they looked at the API calls and they had a lead ID parameters, and their application had a value 64 million, blah, 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 in 742. And then they're like, all right, let's just hit the API directly, but let's not do 72740. And now they're looking at someone else's, like their whole
Yep.
PII, every damn thing. Those attacks get through the defenses, and the reason why is they're not triggering any kind of signature. There's not a SQL payload, right? It just looks like a legitimate request, right? And that's
And
why
it's authorized. It's authenticated. There's a real user account, right?
there's a reason why this is number one on the OWASP top 10 list. So
Yep.
anyways, all that to say, Andrew, like we actually have built a technology that simulates it, right? And it basically will log in as Dan and try to access Scott's records, right? Like it's very hard to detect, but it's not that hard to simulate.
Yeah.
And so hit that like AppySec link at the top. We'd love to show it to you or anyone else that's interested. I had to make a little plug there.
Absolutely. And that was the absolute right time to do it. I want to address
Yeah,
Michael's question here. How do you balance speed
please.
and security when developers push code multiple times a day? And Wolfram's response, I would assume these devs are not caring for security. I disagree with that assessment. It's not that they don't care, it's that they are incentivized incorrectly. So we're talking about as a people problem, right? The dev teams are paid to get features to market fast. And usually they're paid to do that essentially 100% of the time in their available workload hours, right? 40 hours a week, you're a dev, you're getting features to market, you've got things you're measured on, and that code needs to get out. The ops team is there to make sure that those workloads are running and are stable, right? So that's what DevOps has done, is really get it out fast, make sure that it runs. If it crashes, you can reboot it, blah, blah, blah. All that kind of stuff happens. That's dev and ops, right? The security team is there to defend your data and make sure that the organization is secure and to control risk. Those are three separate incentivization structures, right? The ops teams are incentivized on, did your workload stay up? Do you have high availability? Do you have rate limiting applied? Whatever it is, to make sure your workload stays live. That's only covering availability. That doesn't cover confidentiality or integrity. The security team is there to say, okay, so we've got all these things and we're making these investments in order to protect the workload. But how do you measure a negative, right? It's the tiger repelling, the tiger repellent analogy that I like to make. I live in Santa Monica, California. I pay $50 a month for my tiger repellent every month for years and years and years. It's working great. I have yet to be attacked by a tiger. My friends in India may have a different perspective. I think it's India where there's lots of tigers, right? Wherever there's lots of tigers, the tiger repellent analogy breaks down because they're actual tigers and your tiger repellent would be doing some impressive things. But in where I live, it's a useless thing. I'm spending money on the wrong protection. I should be protecting myself against, crossing the street against a red light. That's a much better use of my dollars to make sure I don't step out in front of a car than trying to protect myself from tigers. So the security teams need to justify, how are they spending that money? If they aren't getting hacked, how do you prove that your investment is worthwhile? And that's about metrics and measurement and the maturity of your security program. The developers, it's not that they don't care about the security, it's that they're not incentivized to do it. The other problem is that they're not trained to do it. There's a skills gap, right? So I talked about the silos. Each team is doing something different. There's a skills gap. They're not trained in security. Even today, you go get a degree in development. There's like one elective course that's maybe slightly out of date, but there's like one elective course on security. All the rest of your time is about how to build your loops and how to make sure you're getting things out the door fast in an innovative way that's cool. It's not necessarily that there's enough training for secure development to happen. And so then the third piece is resource allocation. I mentioned that people are paid to do their job 100% of the time. That's part of the problem.
Well,
Your day job should really only be about 70% of your time, and you work on how to improve your work 20% of your time, and 10% of your time should be spent on improving your own skill set.
I want to double click on that 70-20-10 here, but there's an interesting conversation here, right, from Christian. How do you view the association between AppSec and DevSecOps? Often AppSec teams are responsible for SAST and DAST and threat modeling. And then Arthur, well, you test on pushing to master, right? Make the process include security before it's merged. That way it feels like it's part of dev. I love Marie Gang comment. In India, people wait for the tiger attack, right? I think there's a lot in here, right? Like,
Yes.
why don't people do this, right? The question, like, why don't we do threat modeling? There is this, like, people just roll the dice, I think, right? They're like, look, are we really going to get attacked? Are we really, like, this freaking costs a lot of money and all this stuff. Well, maybe we'll just, let's see if we get attacked before we like invest heavily in it, right? And then, and so I
Then they
think
get
a
attacked.
lot of that, right?
Yeah.
And like, and then the last thing I would say is, I was talking to a CISO recently, and they were like, this person was relaying how they were talking to the dev team about an upcoming release. It's coming out in 2 weeks. And they said to the dev team, like, hey, make sure you're doing proper key management in the such and such. Right. And the dev team said, well, you're not going to get that in 2 weeks. Right. Like that wasn't part of the deal. Right. And the CISO said, well, how long would it take to do the key management properly? And they said, well, probably another 2 weeks. And then it said, okay, you got 4 weeks to do your release. But to me, it was this like, what's the number one priority for dev? Like pushing out code.
Yep.
Right.
It's a feature out.
Like features, sales is on them. We need this thing. You got that new release. It's going to drive business, right? And security is this anchor or this drag, right? And so I think that plays a lot in here as well.
It does. And that's the point of, let me go back. That's the point of this cycle, right? You add security one little bit at a time. If you're going to start with testing, right? The name of the course, the name of our webinar today is Breaking the Build Before Hackers Do, right? It's about that shift left idea. You've got your build that's over here on the left. I keep using my mouse as though you can see my mouse working. So on the left-hand side, we have build, right? Your code gets developed. They build it in the IDE. They then push it into a repo where it's going to get built, and you have your Docker container that's constructed or whatever, and that's where your build happens, right? Then you push it into an environment where it can run and for your testing. At each stage, you have different tests that are run. You have maybe unit testing that happens in the IDE during development. You have other tests that are happening in the build stage and other tests that are happening in your testing before it gets released to production. Each one of those in a regular traditional DevOps model is about, does your code work? When you add security testing, it's, do you have SQL injection? Do you have BOLA if you're using API testing? All these different things that can be tested for at different stages. There are API testers out there that test in the dev cycle, right? There are API testers that work in build. You guys need a running environment, if I'm not mistaken. So you're testing more in the test stage, right? Each one of those stages are valid. And the earlier in the cycle you catch it, the cheaper it is to fix, which is why when your CISO analogies just came up a minute ago, how long will it take you to do the key management properly? It'll take 2 more weeks. Okay, cool. You have 4 weeks to get your build out so that they can get both of them ready and everything makes its way out. And I want to address a comment that Randall made. Security nerds slow the go-to-market speed. That's true until you have a mature DevSecOps lifecycle, because each one of these pieces improves your time to market, right? As your tests get better and your devs are catching things earlier, security no longer slows things down. Security becomes integral to your entire operation, because what you've done is you've taken these problems and you've turned them into advantages. And the way that you do that is by breaking down the silos. Amazon is famous. I worked at AWS for a while. Amazon is famous for this 2-pizza team idea. And what that does is it says every team is responsible for their own work product, and it needs to be small enough. The team needs to be small enough that it can be fed by 2 pizzas for a meeting, right? So that's the 2-pizza team idea. And when you take that, it's really a DevOps or a DevSecOps mentality and applying it to business structure. DevOps is really about making sure, earlier he was mentioning, I forget who it was, but he mentioned having your specializations where people are able to cross train and do each other's jobs. That's one way to accomplish it. But if you haven't gotten as far as cross training, still having a workload. Let's say we have the Dan and Scott chat app, right? That we're responsible for. I'm the developer. He's the operations person. And we got a security person off to the side. The 3 of us are responsible for that app, writing it, running it, securing it, maintaining it, updating it. That's our project. That's our workload. We're responsible for it. That's our business unit, our 2-pizza team. Not only is the technology functioning that way, in that it's a chat app that's standalone, but it's also our business process. So when you get to the point that you can have these teams be self-sufficient and support their own microservice, right? Then you've achieved one of the ways that you improve security function within an organization, because security is right there integrated. You got your dev and your ops and your security all baked in. Because of the resource shortage on the security side, usually the security person is fractional. So you'll have like one security person that's assigned to multiple DevOps teams that surround that security personnel, but the resources available, and you have somewhere that the developers can go ask, how do I, and what's the right way for me to do this key management that you talked about earlier, et cetera. But the other thing is, making it easy for people to communicate, making it fun for them to communicate. It's not just about training. It's also about socialization and whatnot. That's how you can really kind of get folks together. And then what you're doing is you're building a security culture. And security culture is how you really accomplish this.
I gotta give a shout out to Randall for winning best comment. I can eat a whole pizza, but I'm also a dev who's obsessed with security. There you go. But like, there's a lot of good stuff in here. My good friend Wolfram, thank you for always being good here. I would go so far that such devs, right, the ones that don't really care about security, I presume, are easily replaced by an AI. I don't know if that was like being funny or reality, but I think AI is something that is disrupting this whole process.
So that you actually hit upon a really good point there. AI is now a tool that we're all using for all kinds of things. Tomorrow, supporting another webinar for ISC2 and CSA, the Cloud Security Alliance. And one of the things that I'm going to talk about is a kind of a top 10 cloud security checklist, right? I'm going to do this little quick overview, and then the Cloud Security Alliance is going to talk about their comprehensive cloud controls matrix. And so in my top 10 list, I added a number 11 to the top 10 cloud security recommendations, which is don't trust AI, right? Don't blindly trust AI is what I really mean. And the reason why is because AI is a phenomenal tool, but it's also like a drunk intern, right? You got somebody who has some skills, but they're also super dangerous and they have incredibly poor judgment. And you wouldn't let a drunk intern start pushing code into production without checking it out first, right? So AI is a great tool, but treat it as a really dangerous, idiotic person that works for you, like the founder's nephew you've been saddled with. Yeah, they can do some things, but they can also really mess some things up. So
Yeah.
real developers with actual chops are using AI every day in order to accelerate their ability to get code to market faster, right? This is going right back to the fundamental question again, right? So if AI now gives them the ability to get code out faster, that means you need to operate it faster and you need to secure it faster. So you need to have your security testing in place. In it, with the concept of AI, there's also prompt engineering, right? You can prompt engineer your security guardrails into your AI development center as well. I saw a really fascinating talk by a gentleman named Jim Manico. I believe that is his last name. Look him up on LinkedIn. He has a really great process around how do you build security guardrails into your prompt engineering at an enterprise scale so that your developers can use this AI capability while still maintaining a secure foundation as defined by your organization's application security team, right? So it's pretty fantastic.
No, that's amazing. My goodness, we're already 50 minutes through this thing. But Scott, please let's bring it home.
Absolutely. So the last thing that I want to just kind of tag here is it's not just about the people, right? I talked about resource allocation and about cross training and whatnot. But there's also process, right? How do you accomplish some of these things? Security Strike Team is a service that we provide where we'll parachute developers in. Earlier, there was a comment that the developers don't care about security. And my thing was, it's not they don't care, it's that maybe they're not trained, they're not incentivized, they're not time. Maybe they don't care, maybe they're not interested, but it's because the incentives are wrong, right? Well, if you're in an organization that has that problem, reach out. We can help you build a security champions program or a center of excellence to help your developers do better. But also we can parachute in a set of highly trained, security-enabled developers in order to accomplish a lot of that work for you. That's another way to approach some of these security challenges. Get your folks to share best practices and whatnot. And then the other thing that I wanted to do is kind of give a quick tease of what parts 2 and 3 of the AppSec University course on DevSecOps are going to cover, right? In section 1, this is the agenda from the course itself on the left, right? What are the stakes? DevSecOps, API security, blah, blah, blah. And then we talk about a lot of the stuff we've talked about today. Part 2 is going to be a deep dive into each one of those specific 14 stages of security around the entire DevSecOps lifecycle with tooling examples for each one. So for example, if you're talking about SAST, maybe I'm going to show some screenshots from Sneak, which is a player that's out there in the static application security testing zone. Obviously, AppSec will be present as part of DAST testing when we're talking about APIs in particular, because dynamic application security testing is about code that's running in an environment. So then part 3 is going to be taking those same concepts, but applying them very specifically to API security. And I believe we're going to put together a whole, more certification around the cycle, API security, beyond just the little quizzes. The way that I typically say it is you can't improve what you don't measure, right? So you have to have a number. You have to have some metric, whether it's green, red, blue, or green, yellow, red, or whatever, for like a qualitative risk assessment versus a quantitative risk assessment, where you're measuring the dollars that are of risk that are exposed. If your metric that your security team is trying to achieve or reducing critical vulnerabilities that make it to production, whatever the number is, then you need to make sure that your teams are incentivized on achieving that objective, right? So your dev team needs to have part of their incentives be tied to that security metric, because mostly what they're incentivized for is to get their code to market fast. Are they meeting the deadlines? Are they getting the features, their stories out, right? But and this is something that needs to happen at the C-suite level, is adjust the the incentive model. Now, the gamification piece can take place at any stage, right? If you got a security champions program, or if you have an AppSec program that's already in place, you can add the carrot, for example. You gamify reducing those critical vulnerabilities. If you can't incentivize it through bonuses and whatnot, then maybe you can have the carrot of a pizza party, or a vacation, or an extra day off, or whatever, right? But the gamification should have something that's exciting for folks to be able to go for it. And even if it's just bragging rights, right? We're going to have a leaderboard, the folks who are able to identify and remediate the top number of vulnerabilities, and make sure that those metrics that you're choosing are appropriate for the organization. We just had a meeting with a customer to present a security champions program that the team was very excited about. And then it turned out that the lead person said, well, actually, the problem that we have isn't the critical vulnerabilities. It's how much it costs for our outside contractors. So it turns out that that security champions program needs to be structured to measure something a little bit different than we thought going into that conversation. Turns out what they want to do is reduce the number of outside contractors that need to come in to assist with that security remediation. So that's about improving developer code security capabilities, so that that outside piece, that outside contractor number, can start to come down. So that's a different metric, right? So then you've got to build your program to achieve that objective that leadership has, right? And then the gamification is, how do you make it fun? So whatever metric you're measuring, how do you make it fun?
Yeah, exactly. Listen, let's call it there. I think honestly, Scott, like this was one of the most active and interesting conversations. I think we're just gonna have you back. Is that cool? Can we invite you back? Thanks to the audience. Like you guys made this super fun, super interesting. Scott, couldn't be more grateful to you for what you put into it. You really, it's an outstanding piece of work. Can't wait to see what you come up with here in part 2 and 3.
Thank you. It's part 2 should be a lot bigger. I'm a little scared to get started on our, to be honest.
Well, we're lucky to have folks like you contribute, your time and expertise, because you can tell you put your heart into it, and it's really outstanding. So everyone, let's wrap it up there.